Ever wondered how your computer sends and receives data over the internet? It's all about TCP and UDP. These two acronyms might sound like a secret language, but they're actually just different ways computers talk to each other. It's a fascinating process, really. When you send an email, stream a video, or browse a web page, the data doesn't travel as one big chunk. Instead, it's divided into smaller parts known as packets. These packets journey through the vast digital landscape of the internet from your computer to the destination. Orchestrating this intricate dance of data packets are two key conductors: the Transmission Control Protocol or TCP and the User Datagram Protocol or UDP. First, let's consider TCP, which stands for Transmission Control Protocol. Think of it as the diligent mailman of the digital world, ensuring your data packets get delivered to the right destination in the right order and in one piece. TCP is like a good conversation. During the conversation or data transfer, it numbers each packet of data. It starts by establishing a connection with the receiving party. This is done through a process called a three-way handshake. Here's how it works. The sender sends a synchronized packet or SYN to the receiver. The receiver acknowledges this by sending back a synchronized acknowledgement or SYN-ACK. Finally, the server sends an acknowledgement or ACK to the receiver, and voila, a connection is established. But TCP doesn't stop at just delivering your packets. It goes the extra mile by providing error checking and correction. Like a diligent librarian, it makes sure every piece of information is accounted for. So, if a packet goes missing or arrives out of order, TCP knows. It will retransmit the missing data or reorder the packets, ensuring that your data arrives just as it was sent. If a packet gets lost or arrives damaged, TCP asks for it to be sent again. If packets arrive out of order, it puts them back in the right sequence. Now, you might be thinking, that sounds like a lot of work. Doesn't that slow things down? Well, yes, it does. TCP can be a tad slower than other protocols because it takes the time to ensure everything is just right. It's like choosing to send a letter via certified mail. It may take a bit longer, but you have peace of mind knowing that your letter will arrive safely and in order. So, TCP provides a reliable but slightly slower method of data transfer due to its error checking and correction features. TCP is widely used in various applications and services across the internet and computer networks. Here are some common areas where TCP is employed. Number 1, when you access websites through your browser using HTTP or Hypertext Transfer Protocol or the secure version HTTPS. TCP is used to ensure reliable and ordered delivery of web page elements. Number 2, TCP is utilized in email communication protocols like SMTP or Simple Mail Transfer Protocol, IMAP or Internet Message Access Protocol, and POP or POP or Post Office Protocol for sending and retrieving emails. Number 3, File Transfer Protocol or FTP relies on TCP to transmit files between a client and a server. TCP ensures a reliable delivery of files. Number 4, TCP is often used in conjunction with SSH for secure remote access to systems. SSH is secure shell. It provides a secure and reliable communication channel. Number 5, TCP is used alongside UDP or User Datagram Protocol in DNS or domain name system. While DNS queries are typically handled using UDP, TCP is employed for large data transfers and zone transfers. Number 6, Remote Desktop Protocol or RDP, used for remote access to computers, relies on TCP to establish a reliable connection for desktop sharing and control. Number 7, Server Message Block or SMB, which facilitates file and printer sharing in Windows networks, uses TCP for reliable data transfer. Number 8, TCP is commonly used in database management systems like MySQL for establishing reliable connections between clients and servers. Number 9, secure transactions over the web, such as those used in online banking applications, often employ TCP in conjunction with HTTPS for encrypted and secure communication. Number 10, TCP TCP can be used in voice over IP or voice over internet protocol applications for signaling purposes, ensuring that call setup and teardown processes are reliable. Next, let's dive into UDP or User Datagram Protocol. Unlike its counterpart, TCP, UDP plays by a different set of rules when it comes to data transfer. Imagine if sending a letter was as easy as writing it and simply throwing it out of the window, hoping it would reach its destination. That's somewhat how UDP works. UDP does not establish a connection before sending data. It's like a postman who doesn't knock on your door to make sure you're home before leaving the mail. Instead, he just drops it off and goes on his way. This is what we call a connectionless protocol. It's all about speed and efficiency without any handshaking dialogue. However, there's a significant trade-off here. While UDP is faster because it skips the time-consuming process of establishing a connection, it doesn't ensure the delivery of the data packets. It's like the postman tossing your mail without checking if it landed in your mailbox or your neighbor's fish pond. Furthermore, UDP does not check for errors or correct them. It just sends the packets regardless of their condition or order. This is what makes UDP less reliable than TCP. It's fast, but it doesn't guarantee that your data will arrive in the correct order or even arrive at all. So UDP offers a faster yet less reliable method of data transfer compared to TCP. UDP is all about speed. It sends packets of data across the internet without checking if they've been received. Now, this makes UDP faster than its counterpart TCP. So if speed is your game, UDP has got your name. But remember, it comes with a little risk. UDP is used in various applications and scenarios where real-time communication, speed, and low latency are prioritized over reliable and ordered data delivery. Here are some common areas where UDP is employed. Number one, voice over IP or voice over internet protocol applications such as voice and video calls often use UDP because it offers lower latency compared to TCP. Real-time communication benefits from the speed of UDP and any lost packets can be acceptable. Number two, multiplayer online games utilize UDP for its low latency characteristics. The immediate responsiveness required in gaming makes UDP a suitable choice even if occasional packet loss occurs. Number three, live video streaming and online multimedia applications often prefer UDP. Protocols like RTP or real-time transport protocol and UDP-based variants of HTTP, example UDP-based HTTP adaptive streaming, are used for efficient media delivery. Number four, while DNS or domain name system primarily uses UDP for its query response mechanism, it can switch to TCP in certain cases such as for large data transfers or zone transfers. Number five, DHCP or Dynamic Host Configuration Protocol uses both UDP and TCP for client-server communication. UDP is used for the initial stages of DHCP to obtain IP addresses and configuration information. Number six, NTP or Network Time Protocol, used for time synchronization across networks, relies on UDP. The lightweight nature of UDP is sufficient for the purpose of time synchronization. Number seven, Simple Network Management Protocol or SNMP, used for network management and monitoring, can use UDP for communication between the management station and the managed devices. Number eight, TFTP or Trivial File Transfer Protocol, uses UDP for its simplicity and lower overhead compared to TCP. TFTP is often used for lightweight file transfers. Number 9, IoT or Internet of Things. Some IoT devices and applications use UDP for lightweight communication where the emphasis is on low latency and reduced overhead. Number 10, UDP is suitable for scenarios where data needs to be sent to multiple recipients simultaneously, such as in broadcasting or multicasting. Now that we understand TCP and UDP, how do they compare? TCP is akin to a reliable postman. It's slower due to its meticulous error checking and correction, ensuring that all of your data packets arrive in order. On the other hand, UDP is like a sprinter delivering messages. It's faster, but it doesn't guarantee delivery or order. So, depending on the application, either TCP or UDP could be the better choice for data transfer. In the world of data transfer, it's all about balance. Whether you choose TCP or UDP, it all comes down to what you value more, reliability or speed. Thank you for joining me today and keep tuned for my next video. Take care.